Hello there again, more PWM nonsense, and this is a little fan controller. It varies the speed of a fan using a PWM signal, and it's for, well, it's got a thermistor, so it's temperature sensitive obviously. But before I get into all that and how it works and whatever, and look at it on the scope, I'll just show you what it's for, what the project that it's going to be installed in. Okay, this is a monstrosity. There's no other word for it. I built a few months back for my friend. You've never seen so many knobs on the front panel before, and so many input sockets as well. Basically what it is, it's a big powerful Class D amplifier, and it uses 6 boards. There's 2 high power ones, relatively high power, 160 watts. 4 of those, one there, one there, one there, one there, and then they're 4 channel boards, and no, they're not, they're 2 channel boards, and then we've got a 6 channel board there, another 6 channel board there. These 2 4 channel boards drive the bass speakers, and these 2 channel boards drive the mid-range speakers, and then we've got tweeters coming off one of the 6 channel boards. And as they had 6 channels, it was decided I ought to use them all up, so they're all being used and all controlled by various knobs on the front panel. But that's getting away from what I wanted to talk about today. I originally installed fans in this, and I had 2 over here, one there and one there, and on one side I think they were blowing out, and I had another 2 installed over here sucking in air, so that you get air passing over the boards, hopefully cooling it. Now originally these are actually 24 volt fans, but the guy I was doing it for was a bit concerned about how noisy it would be with the fans running. So what I did was I wired them in series. So basically you had 2 over here wired in series, so they were getting 12 volts each, the fans, even though they're 24 volt, and the other 2 there wired in series, and then parallel the lot up. But having finished the project, I hoped, I gave it back to him, and he wasn't happy with the fan noise, so that's fair enough. And also the fact that where I'd mounted the fans on the other side of there isn't a lot of cutout for the air. I mean, these are just small ventilation holes, so it's going to impede the air input. So I've got to cut all this out on each fan, and install a fan guard on there as well. And down there's a voltage regulator, which I recently installed. That's an OM317, one of the higher power versions, and that will drop the 37 volts, which is what this thing runs on, 37 volts DC. That will drop it down to 24 volts DC for running the fans via the fan controller. So now we'll go back to the fan controller and have a look at it. So we're back to the actual controller I bought. 13 quid on eBay, which is fine. But so what have we got here? We've got basically pulse width modulated output to the fans, and you can have two fans connected, which is quite nice. So it doesn't involve having too many wires in one socket. That's your DC input there, and runs on anything from 12 to 24 volts. That was the initial problem. I couldn't find, it was hard to find a unit that ran on 24 volts, but that's fine. I got this one, and if we look around the circuit board, there's a few obvious things. There's a 7805 regulator to drive the chip that does the fan control, and we've got two fairly powerful MOSFETs. They don't have to be massively high current, because this thing's only rated at 2 amps maximum, and measuring all the fans running together, they draw 600 milliamps, so that's fine. And then we've got, which is obviously the control chip, and I struggle to see the number on it. Eventually, using a watchmaker's eyeglass, I did get the number off it, and it appears to be, but would you believe it, a fan control chip that does the pulse width modulation and works off a thermistor. And here's the thermistor, and the whole unit works by it's got two modes for a start. It's got an automatic mode, that's what this switch is for, and an adjustable mode. In the automatic mode, it doesn't start the fan up till you get to 30 degrees C, which is absolutely fine. You don't need a fan below that. And then maximum pulse minimum pulse width, or what effectively is pure DC, is achieved when it gets to 100 degrees C. So between those temperatures you'll get a varying pulse width between 30 degrees and 100 degrees C. It's also got an LED on it which says your power's on, and that one there just lights up when it's pulse width modulating. And there's the, if I put it in the other mode, which is the adjustable mode, then you can set the actual turn on time of the fan. So you might want it to come on at 20 degrees for instance, or not till 40 degrees, whatever you want. You can set that with that potentiometer with the switch in that position, and I think it's a nice little board. Few resistors, few diodes, nice little connector on the side. As I said, DC in and two fan outputs. These two fan outputs are shorted together, in other words, that positive is shorted to the other positive, so it's not like they're using the MOSFETs individually for each channel. So there you go. So let's now try it out and look at it on the scope. So it's all wired up now with just a single fan, and that's the scope. We're going to look at the pulse width when it starts up. Initially I'm just going to hold on to this terminal. As I said, it should start up, which it did, at 30 degrees, but it's a hot day and I'm hot, so that sounds reasonable. And if you can see down there, we're getting a 46% duty cycle, so that sounds reasonable. But if I let go of this and let it cool down, I've got the sensor in front of the fan now. You can gradually see the duty cycle dropping to 40, 38, 37, 36. So the minimum it will do is 36%, and then it just turns off because it's reached below 30 degrees. Well, that's probably quite a good idea, because any narrower a duty cycle than that, and these fans just stop working anyway if they're too low a duty cycle. So in order to try it at higher temperatures, I thought, how can I warm it up? You know, thought, should I stick a soldering iron on it? But that's a bit how you doing, isn't it? Sticking a soldering iron up on the poor thing. So I've got here a glass of hot water. So I'm now going to stick this probe in the hot water. I just start it off just with the end inserted. Takes a while to and there we go. And I want to try and see it increase gradually. And there we are, we're up to 60% duty cycle now. This water, I think, was not far off boiling point. And we're up to 71%, and the fan speed's going up. Now we're getting up to 85% duty cycle, and I can see my face in the screen, which is annoying. I don't want to see my face in the scope screen. Anyway, we're up to, what are we now, 99, and then it goes into pure DC. So I think that's pretty damn good, really. Says we're only getting 23.5 volts. I guess there's a bit of drop somewhere in the circuit. Okay, let's take it out of the water again and hold it next to the fan, and we can see it gradually coming down again, of course, down to 85, 83 duty cycle. And soon be down to 50%, 55, down in there, 50, 47, 42, won't be long now, 36, and it cuts out at 36. So that was fairly successful. So I think, all in all, I am quite impressed with this little circuit board. It looks well made, and I think it will do the job fairly well, if not perfectly. Now I've just got to look forward to cutting all that metal out, which is not going to be a very pleasant job. So there's more metal on the case, I mean. So there's more space for the air to flow through. I'm expecting some fan grills to turn up this afternoon to go on the outside. I just bloody hope they're the right size. There's so many different sizes. These apparently are 90mm fans, and that's what I ordered, so I hope they fit alright. Anyway, a bit more PWM nonsense for you, so bye for now.